Hey class, we are here for Module 4, Lesson 14, which is actually on the same topic as Lesson 13. It's when we are finding the area of sort of rectangles that either have missing pieces or extra pieces added to them. We're also going to do some word problems that involve some of that similar work to what I just described. So I have the problem set with me here, so you've already had a chance to work on this independently in class. We've gone over a little bit of it, but this is another chance to look at it. Either to clarify or to help you with your homework. So here we go. Let's take a look at what we have. And this work is a little bit more challenging than in lesson 13. So the problems just have an extra layer of complexity to them. So let's go. So this first one says find the area of the following figures. All figures are made up of rectangles. So again, we always have two options, or we can either complete this rectangle, right, and then subtract out the missing portion. We can do that. Or we can find the area of rectangle A and rectangle B and add them together. And in some cases, both strategies work equally well. And in some cases, one is preferable to the other, meaning that one would be easier for you than the other. In this case, I think that I'm going to complete this rectangle. And I'm going to say that this, we already know that this right here is 2. So that side length is 2. And if this from here to here is 3 centimeters, then on this side, this is 3 centimeters. So I can already tell you that the missing part equals 3 centimeters times 2 centimeters equals 6 square centimeters. So this is 6 square centimeters. Okay. So I know that eventually I'm going to have to subtract that piece at the end, right? Because it's not actually included in the figure that we're trying to measure. So eventually we're going to subtract this from our total. Now we need to go about finding the total. And so in this case, it doesn't just give it to us like in lesson 13 it would have. We have to sort of figure it out. So we know we have a length of 3 centimeters here or here, and we know we have a length of 2 centimeters there. So this whole thing altogether is 5 centimeters. We have to add those two side lengths together. You're going to have to do a lot of that work where you understand some of those principles of geometry or rectangles specifically in this case, where opposite sides have the same side length. So if that's 2, then this is 2. If that's 3, then this is 3. So we add that 2 and that 3 together to get 5 centimeters on that side. And then down here, we have 2 from there to there and 3 from there to there. That also is 5 centimeters. So my total with missing piece is 5 centimeters times 5 centimeters, which is 25 square centimeters. Okay. So just the shaded part, so these are two things I figured out so far. Shaded part, it's probably hard to tell in the video, but this is technically shaded. It's very lightly shaded, but it is shaded. Equals 25 minus 6 equals 19 square centimeters. And that's the area of the shaded part, is this right here, 19 square centimeters. Now again, you could have found this as being 3 times 3 is 9. You could have found this as 2 times, you add these together and get 5, and you could have found that as 10, and you could have added those together as well. That would have worked just fine. All right, let's move on to the next one. So this one we have, oh, I went a little too far. There we go. We're going to find, again, the shape of this, or the area of this lightly shaded figure here. Looks a little bit like a block C. Now I have a couple options. I could divide it into 3 rectangles, either here and here, or here and here, or I could find the whole thing with this missing piece and then subtract that missing piece. I think that, I think that's what I'm going to do. I'm going to fill in this gap here. I know that this must be 2 meters. right? Because the total length of that side is 4, which means the total length of this side has to be 4 meters. And I already have 1 and 1. So you're just thinking like 4 equals 1 plus 1 plus something, and that something has to be 2. 2 plus 1 plus 1 is 4. Right? I know that this side length has to match that side length. Okay. And they told me down here, if you look down here, it's saying that from there to there is 1 meter. So I'll label it again up there. So 2 meters, so missing piece is 2 meters times 1 meter. Equals 2 times 1 equals 2 square meters. Okay. Now the whole thing, if I multiply it all together, is 4 times 3 because you add this 2 and this 1 together. So this whole top is 3 meters. Right. Total equals 4 times 3 equals 12 square meters. So the shaded part equals 12 minus 2, which is 10 square meters. So in that case, I think it was probably easiest to do it the way that we did rather than split it up. I mean, you could have done that and that, made that 1, made that 1, and made this 8 and added 8 and 1 and 1. I guess that would have worked just as easily. So again, there's the part of this set of lessons I like the best, and I told you this in class, is that you guys get to demonstrate a lot of different problem solving abilities, and I get to see how you're thinking about things just by the approach you take to each problem, and I really enjoyed that. And I like that it gives you a lot of flexibility and choice in how you go about solving problems. All right, this last one on the front side says this figure shows a small rectangle within a big rectangle. Find the area of the shaded part, and the shaded part is the outside. So we're going to cut out the center part. And this one's just the way it's labeled is interesting. We know the whole thing, the total, let's find that right away, is 30, right? We have 5 meters and 6 meters. So that means this whole side and this whole side are 5 and 6. 5 times 6 equals 30 square meters. Now I need to figure out the side length of this and this. Okay, this is a little bit trickier. This takes a little bit more. You got to really look at the problem and see like what information do I have, what information do I need. Well, this whole side from here to here is 6. So we have 6. I'm gonna do it down here. 6 minus 2. Right? Because this part's shaded, so we can't count that in our white section. And then minus another 1 is going to equal, this is the white length. 6 minus 2 minus 1, so that's 3 meters. So we know that this is 3 meters long, right? Because 2 plus 3 plus 1 equals 6. So whatever we put in here just has to make this true. When we add up all the other measurements we have, it has to add up to that total right there. Now, same thing for our height. We'll do that. White height is 5, right? The whole thing from top to bottom is 5. 5 minus 1 and minus 2 more. So 5 minus 1 is 4, minus 2 more is 2 meters. So this is 2 meters. And again, 1 plus 2 is 3, plus 2 more is 5. So I have 30 minus 2 times 3. So 30 meters, square meters minus 6 square meters. So I have the whole thing, including the white cutout, minus that white cutout is going to give me the shaded part. And that's going to equal 24 square meters. And that is our solution. So again, that one took a little bit more. It's the same process basically, but the way it's labeled, with them being labeled on the inside rather than on the outside, causes you to have to think a little bit more carefully about how you're going about solving the problem. All right, let's do a couple of quick word problems involving this same sort of thing, and then we will move on. And the next lesson will be our review for our end of module assessment. All right. So paper rectangle has a length of 6 inches width and has a length of 6 inches and a width of 8 inches. So I'm going to just sketch that loosely. 6 inches and 8 inches. Okay. A square with a square, that tells me that the side lengths are going to be the same on whatever we're talking about here. With a side length of 3 inches was cut out of it. Ooh, okay. So let's draw that. So this is, I don't know if you can see this dot. There you go. 3 and 3 was cut out of it. What's the area of the remaining paper? So of this part right here, we're going to cut out that section. So my whole area is 6 inches times 8 inches equals 48 square inches. Right. Now I'm going to subtract the this square down here, which is 9 square inches. 3 times 3 is 9. So cut out 3 inches times 3 inches equals 9 square inches. And what's left over, like in this case, the paper that's left over after we've cut a piece out, is 48 square inches minus 9 square inches equals 39 square inches. So I would say like the actual math of that was easier than anything that we did on the front side of the paper. However, the challenge there is you have to be able to read that problem, pull out the required information, and understand what it means. So you have to be able to draw a figure like this as you're reading, right? Some of you might be able to do it without drawing a picture. You might just understand what needs to be multiplied. You could just do this part, right? Like you understand that. But I think it helps to draw a little sketch, just so you can have a good picture of what's going on in your head and make sure that it all makes sense before you start problem solving. All right, we have one more similar problem down here. All right, let's call them T and E. You know how we don't want to let names get in the way of our problem solving in math. So T and E both have paper rectangles measuring 6 centimeters by 9 centimeters. So they're both starting with the same thing. So I'm going to do T and E. They both have rectangles 6 and 9. I know my rectangles aren't exactly the same size, but the numbers are labeled the same, so that works. T cuts out a 3 by 4 rectangle, so she cuts out a, let's see, 3 by 4, so 3 by 4. And Evan cuts out a 2 by 6, so a 6 and 2. Okay. So T says she has more paper left over. E says they have the same amount. Who's correct? Show your work. So basically, we have to find how much area is remaining. I'm shading in the part that gets cut out. So we're going to try to figure out how much white space is left there and how much white space is left here. Well, the total in both of these cases, like the starting total, equals 6 times 9 in centimeters. So I should probably label those. So we have 54 square centimeters for both. All right, so the cutout is 4 centimeters times 3 centimeters in this case. So that's 12 square centimeters. And in this one, it's 2 centimeters times 6 centimeters, which is also 12 square centimeters. I think at this point, you probably can see where this is going. We have the same area to start. We're cutting out the same amount of paper, which means we're going to have the same amount left over. So left over. So we have 54 minus 12. That is 42 square inches. And the same is true over here. Okay. That's it. They have the same. So E was right because he said that they had the same amount left over, and we were able to prove that showing our work. And again, drawing those pictures just helps you to understand what's going on. So I would have guessed based on my drawing that E had more left over. So it's important not to just look at the drawing and say, I think I know. You really need to do the work and show the math. So I'm always going to ask you to show your work and really demonstrate that you understand why, or sort of support your answer. Say, this is why I feel the way I do, with equations and numbers and things like that, rather than just state that they're the same or state that one has more than the other. But that's not news to you guys. You guys are used to that expectation in our class. All right, good job. This sort of wraps up module 4, and we will do a review. We'll do another area-based activity later in the week, and by next week we're going to be moving on to doing some work with fractions. So excellent job this module. I think you guys did wonderfully, and I really enjoyed hearing how you were approaching all these problems and seeing how creative you got with your problem solving.